Yeah, you're getting it.
Okay, let's roll. Hi, welcome to Factbird's Manufacturing Matters podcast. Today I'm here talking to Esben. Hi, Esben.
Hello.
We're in the offices of Onomondo, a cellular IoT provider. And yeah, could you introduce yourself and tell us a bit about what you do?
My main focus is on larger and complex sales cycles and customers with extraordinary needs when it comes to IoT devices and also their architecture.
Okay, cool. Yeah, and you've got some customers that are manufacturers as well, right?
Sure, yeah.
And that's why I'm here talking to Esben today, because connectivity is obviously very important in manufacturing, be it with Ethernet, Wi-Fi, or cellular. And cellular is a very good way and continually improving way to get connectivity on sites. So first of all, I wanted to ask you, what is cellular IoT, just to set a base?
Well, it's a fairly straightforward answer, actually. It is using cellular network to have devices talk to each other, M2M, machine to machine, and using like the normal understandable radio technologies, so 2G, 3G, 4G, 5G, NB-IoT, Cat M1 BIS, LTE-M, these kind of things that are making devices, enabling them to have interactions. Mm-hmm. So it's making things talk to other things.
Yeah. It's people always used to call it M2M. Yeah, it's always changing, and now it's IoT, and then there's all the different standards.
Yeah.
I remember LTE1 or LTE Cat BIS or whatever it was. Really
Cat M1.
Yeah, Cat M1. Thank you. So then, why is cellular popular then, compared to other connectivity methods? What are the pros of it?
Well, it's much more accessible. The infrastructure is rolled out heavily. Mind that M2M and IoT devices are using and piggybacking on already existing cellular networks used to more like B2C, so customer-facing networks. So they're using different kind of bands on those cellular networks, but the infrastructure is there, and it's very, very much like global, as you can see.
Yeah, I know. That's why. So Factbird's a customer of Onomondo, and that's why it's really good for us, because a device can be shipped anywhere in the world. People turn it on and it works. It's connected. Cellular is great for that. So then, what are some use cases for cellular IoT in manufacturing?
Well, like from our point of view, it's very much to do with there's obviously different kinds of setups on factory floors. It can be sensors on machineries. It can be down to access control to the factory floor, and it can also be equipment tracking. So there's a lot of different kinds of overarching use cases for it. But I think one of the things that really is the thing that brings it all together is the predictive maintenance aspect of it. Because that's an area where cellular connectivity has really shined. And that is to be able to get real-time information on devices, on their setup, how many cycles have they been doing, and that can then be dragged back into what do you call it? A cloud system. And then by using either different kinds of algorithms or AI, figuring out when do we need to act on different kinds of devices, meaning that we know that a CNC machinery would, after 10,000 cycles, need to get these parts changed.
Yeah.
And by that, you are then able to do one of the things that is key in this is the predictive planning. So, because sending out specialists to these factory floors is a huge cost. So being able to make sure that when you send people out, you don't send them out because it's needed now, because it's going to be needed in 2 months' time, for instance. And by that, you can then group devices and say, well, I'll do these 10 machines now, because they will need to have some kind of maintenance done within the next 4 weeks or 8 weeks or 2 months. And by that, you optimize the time needed to get to the machinery, and most importantly, you remove the downtime by predictably maintaining the systems.
Yeah, and downtime is very expensive. We want to avoid that. That's what Factbird's built its business on. Okay, can you elaborate? Do you have some specific examples of cellular IoT in action?
Yeah, sure. Well, one of the areas was, for instance, CNC machinery, which is huge machines like for cutting into metal or different kinds of materials. And these machines are about like 5, 6, 8 million euros. Like the cost base is huge for these, which means that it's a big investment, and it's extremely important to know that, like, that if they break down, it's extremely costly on the loss of production time, but also that the materials that they need to maintain the machines are also expensive. So this is also something that needs to be put into a kind of a spreadsheet, more or less, so you know when you have different kinds of costs coming your way.
Yeah.
And this is what like these things can help you do and achieve. So you have a much more predictive understanding of what is the cost base of budgeting for the next 5-10 years, because these machines can easily like work for decades.
Yeah.
And historically, like, because these machines are like fairly heavy on data consumption, because we're looking about maybe 88 to 90 sensors, and sensors from like cycles on different kind of moving parts down to like temperature, humidity, overall like density sensors. There's a lot of things that is happening at the same time, but there's also sensors that are actively looking for organic material, meaning people.
Yeah.
Because these are fast-moving machineries, they're dangerous. So that they also need to be able to monitor and foresee if anything is in the way. It can also be like a rat, and that could actually create heavy damages on the machine.
Yeah, if it gets in somewhere.
Yeah. So that's kind of where, like, historically, latency has been a big thing, because it's like that needs to be reacted on fast.
Can Cellular offer low latency connectivity?
To a certain extent, because like historically, like factory floors for decades have been serviced by something called field bus, which is basically like it's EtherCAT, it's Modbus, it's cabling. So it's a closed environment, but that also creates what's called an air gap, meaning that it's a closed system without any kind of connectivity towards outside.
Yeah, so good in that aspect of cybersecurity. Yeah.
Well, if there's no connectivity, then there's no kind of way in, you can say.
Unless somebody just walks in.
Yeah, but there's also no way out.
Yeah.
Meaning that's kind of what Cellular can do. And I think when we are seeing Cellular has been matured heavily. I don't want to see that 5G is going to solve everything, but 5G has the ability to help a lot on the direct device management, because suddenly you have the latency aspects are getting more manageable.
Yeah.
But I think the most important thing about it is that you are able to get information out to a centralized space, and to be able to actually start working on that data you have. So it's not just a question about taking the temperature of your device, of your machine out on the factory floor, but it's also figuring out like how can we optimize, where's the small optimizations aspect we can work with. And again, in a volatile world as we live in right now, where things more or less changes on a daily basis, this is where like things like that comes into play.
Yeah, so Cellular is a really good way of getting the data to a server that can help you make it useful.
Yeah.
And then there's all the options with, I saw Amazon's got a new like European enterprise sovereign setup for people worried about data security and all that, but you're never going to have the computing power of Amazon or Microsoft or whatever in your factory, so you want to get it out.
You need to get it out, because it's not a sustainable setup to have it on-prem. That will never ever give you the return of investment that you have to put up to be able to do that, and also it's not agile.
Yeah.
But again, but we have to understand, especially like in industrial IoT is a fairly new vertical, meaning that but the industrial industries have been around for ages, meaning that we're up against something that has been put in place for decades, and also we were up against infrastructure that has been put in place to last.
Yeah.
So there is a maturing that needs to be done there. It's the classic digital transformation that we see so many other places in the world. But problem is that in industrial setup, it's very pricey. There's a big investment into infrastructure, meaning that changing that takes a lot of maturing, both on the customer side, but also on the technology side.
And introduce new technology, it makes it's complicated to get the people on board with it as well.
Sure.
Yeah.
The classic situation has always been that we'll hook all our devices up to our local LAN because we know that works and that's fantastic. It's going to be great, or we'll hook it up to our local Wi-Fi on the factory floor because then it's cheap, it's easy, and we can handle that. Problem is then that suddenly a new IT head comes in and changes something, or a new firmware update has come out for the Wi-Fi that changes something. So, and then suddenly you're depending on a single point of failure.
Yeah.
Then there was a move into having every single device having a radio module, so a modem with a cellular connectivity aspect on it.
For redundancy.
For redundancy.
Yeah.
Then you came into black spots or fogging on the factory floor because again there's a lot of metal there, and metal and cellular connectivity is not normally the best of friends.
Yeah, if you're welding or like there's a lot of electricity flying around. And
exactly. Yeah. So it's trying to figure out like understanding your own factory floor first of all. Understanding your like what are the different kinds of things that can have have an impact on your connectivity, and then most importantly, like how many times do you need to have data coming from your devices? Is it daily? Is it weekly? Is it per minute? Is it real time? Is latency a big question? So all of these things come into play when you have to start designing for like a cellular implementation into your factory floor.
Making connectivity decisions. Yeah.
Yes, exactly.
Yeah, that's really good. So cellular's started to become popular as a way to build in redundancy. Now it's actually with 5G, low latency. There's even more use cases for cellular IoT. You have to be aware of your coverage mapping with fogging, right? In the factory.
And it can be various things. For instance, if you also have a warehouse aspect near your factory floor, depending is it full, is it empty, that can have impacts on how you are able to get cellular connectivity out.
Yeah. But there are some good ways to help with that, right? And Onomondo specializes in that.
That would be like a local, like a private network that you set up, which basically acts as a cell for the factory floor. And then all the modules, all the radio modules will see that as a cell, and they wouldn't be seen as, it will look exactly the same as any other connecting cell out there. And by that you will be able to have full ownership of your connectivity on your factory floor, and at the same time also have the backhaul that you decide whether it's fiber, satellites, it's or another kind of cellular setup that is a different place away from the disturbances that could arise.
I can imagine a lot of large enterprises find that really valuable, having a
extremely
private,
valuable, yes,
cellular network in the factory.
Also security-wise,
with the load balancing aspects of, we're talking to this guy from South Africa, and I remember that cellular, there can be issues in South Africa or Africa, for example, with all of a sudden connectivity going down. With
load shedding. Yes.
Load shedding.
Yeah.
That's the word. That's what I was looking for.
I work quite a lot in Africa, so I've seen this very, very close.
Yeah. So if you got your private network, you are less susceptible to problems like that. Yeah.
To a certain degree, yes, because there is also the basic of power.
On the power.
Yeah, and also backhaul. But again, that depending on the urgency and the value of the data that you're handling, there's always some kind of a non-terrestrial, so satellite setup you can use, or you can also like fibered or cables solutions as well.
Big investment, but it's worth it.
It's a big investment, but again, this depends on what kind of setup you're having, because there is mining industry, for instance, are heavily relying on having a constant backhaul of data from the pits, from their quarries, rock crushing machinery, and then also overall tracking of all the machinery that is working everywhere. So they basically are becoming their own infrastructure owners because they need to make sure that this is something that they constantly are able to backhaul.
Yeah, because it's such a important break point.
Yeah,
so when connectivity goes down, you lose visibility of everything. Then things
start to go really, really sour, really, really fast. And it's not just about value; it's also about having the sustainability aspect of it. Because, for instance, mining being a fairly polluting industry.
Yeah.
They need to be constantly aware and able to provide information about how are they handling like spillage, surplus, all these kind of things. And if there's issues on that, then it's something that can be penalized on local authority area. So these are things that where it suddenly becomes very, very practical to have the ability to monitor every single thing by itself, but having it in a engulfing private network, for instance.
Yeah. Okay.
And security being the main driver there as well.
Yeah. Yeah, that's a lot of good food for thought. So cellular is good for building redundancy. Cellular is good for getting data to the cloud. Cellular, private cellular networks, especially for large enterprises, are really good at looking into that. Are there any tips that you can give or best practices for companies other than ones that you've already given for using cellular IoT?
I think from my point of view is bring in the connectivity partner as early as possible.
Yeah.
In the design phase.
Yeah.
Don't build everything and then, oh yeah, by the way, we need a SIM card. Because like that, then you lose out on a lot of knowledge and a lot of experience from connectivity providers being able to guide you. And also because when we're looking at industrial in IoT, where we're looking at investments 10, 20 years, right now we are seeing, again, a volatility when it comes to sunsetting different kinds of radio technologies.
Yeah.
So like in 10 years time, if you're depending on a modem that only has a certain spectrum to be able to work within, that could potentially be sunsetted.
Yeah, so people are used to thinking of their phones, I guess, and it just works.
It just works, yeah.
You replace that, and it's kind of the B2C version of cellular is different to the B2B version in ways, yeah. So 2G's gone pretty much everywhere.
It's being sunset.
Yeah, it's been sunset for a long time.
For a long time, yeah, for a decade more or less. And some are faster than others.
Yeah.
But also interesting areas like NB-IoT, so narrowband IoT, which everybody was banking on would be kind of, that's going to be the most interesting thing in the world.
That was pushed by Huawei, right?
Exactly. That has been sunset by several of the larger operators, both in the US. Docomo in Japan was the first one to say, like, you know what? We build it, it works perfectly. We don't have enough use cases, so we cannot justify having it around.
That was a made for IoT network. It was
100%, yeah.
And that was using the 2G bandwidth or whatever, and then
but now then a new radio technology has emerged within the last year or two, and which is called Cat 1 bis.
Yeah.
And that actually uses the normal LTE network, so 2G, 3G, 4G. But 5G, much more versatile, but it still acts like a narrowband. So it's very much it's very good for like data consumption, low data consumption, low power consumption, and low latency as well.
And this is all stuff that people don't want to think about.
Exactly.
So that's why you bring in the connectivity partner early.
Exactly. Don't see it as just a commodity. See it as that it's a landscape architecture you need to build into, and especially if you're global. Because that's a whole different kind of headache. And so because legislation is changing constantly, we are seeing security being absolutely focused from everybody. Everybody's only talks about is security, and which in my world is fantastic because it's been too easy to just slap something on a device and say, great, now you have connectivity, and then it's an open back door.
Where's it pinging to? What's happening?
Exactly. So and a lot of these devices are built in a way that doesn't take that into account. It's not that people are maliciously trying to ruin things, but it's not being built for it properly. So, but luckily now we are heavily engaged with FCC and the CE certifications here in Europe to make sure that when we start a project with a customer, we make sure that things are certified. Because otherwise you can have a full rollout that suddenly just gets stopped because it's not certified. We saw it with ZTE in the US that because of the trade war under the first Trump presidency, suddenly they banned everything from China. And suddenly a lot of the large operators needed to change their entire core structure.
On the towers and that.
Exactly. And so let's try to be smart about this.
Okay, well, that's a lot of really good insights. We could geek out on connectivity forever, but I think we've got some really valuable stuff in there for the beginning for manufacturers to take home and use.
Cool.
Thanks for your time, Esben.
Pleasure.
Let's get out of here.